So this is an introduction to logarithmic functions, and today I'll be going over what a log function is, how it relates to an exponential function, and how to solve for log. So the parent function of a log function is log b of x, and you can transform it by adding a multiplier, which basically doubles, triples, stuff like that. And you can change it right or left and up or down by putting numbers there. So basically, a log function is the inverse of an exponential function, and an exponential function is basically something to the power of something. So you could say, sorry, you could say 2 to the power of 2 equals 4. That's an exponential function. The log one would be log of 2 over 4 equals 2, and I'll be showing you how to do this in a bit. So as I said, 4 times, well, this is 4 to the third power equals 64. This is basically saying it's 4 times 4 times 4. So the first step is to analyze the equation. You can see that it's 4 to the third power and is equal to 64. First, you add the word log, and you put 4 as its base. This number is the base. You then switch the 3 and 64, so that would be, so if I do that, it'll be, you'd switch both of these, so it'd be log of 64 equals 3. And then you put the 64 in and the 3 after its equal sign. The final answer is log 4. That's how you do it. So here's some practice problems to do. Just pause the video and do it. I'll start showing the answers in about 5 seconds. So the answer to this one would be, you'd add the word log, obviously, and then you would bring 6 as the base, and then you would put 53 equals x, because you switched the places between these two. The second one would be log of x would be the base, 73 would be in parentheses, and it would be 5. You'd switch both the positions again. So, solving logs on one side. So let's just say the problem is log of 9 of x plus 22 plus log of 9 of x equals log of 9 23. So first things first, you see if there is a common base. In this case, it's not. You would condense the log functions, which basically means, like, on the reactant side, there will only be one log of 9. So you condense it, and if you do that, it would be x over x plus 22 equals log 9 23. See, and then you would basically distribute the x to each of the variables after that. And then you get x to the second power plus 22x equals 23. And then you would just, and if you pay attention to the last unit, you would understand that this is a quadratic function. And you basically solve it like a regular quadratic function, and you would get x equals -3 and x equals 1. So in this case, x equals -23 is an extraneous solution because log functions do not, they don't understand negative x values. Here are a couple of practice problems. Just pause the video. I'm just going to go ahead and show how to do them. So first things first, you would just condense it, log of 7, and then it would be 2x squared. I just went ahead and distributed instead of doing the parentheses stuff. 2x squared plus -4 equals 2. So you would get 2x squared plus -4 equals 2. As I was saying, before. These are the two answers you would get for that problem. It would be x equals 1.73 and x equals 1.51. 1.73 would be the more better answer to go with, because negative 1.51 is the extraneous solution. And I also worked out the other problem. So you do log of 2x, x plus 1. You would distribute in the parentheses, so that would be x squared plus x equals 1. And then you would get the answers x equals negative 1.66 and x equals 0.61. You could also plug both the answers for these ones into the equation and see if they work out, if you get 1. So solving logs on both sides, this is way easier. So first things first, you have to look at the base, and then you have to analyze the question. So basically, just look at the base is the same one, and as the base is the same, drop the logs on both the sides and solve like a regular equation. And then remember to plug in that answer you got the equation to see if you got it right. So let's just say it's log of 2 and it is 3x, and then it's equal to log of 2 3x. So basically you would just take out both the logs, you get 3x equals 3x, solve it like a regular equation, you get x equals x, and then your answer is basically x equals infinite amount of solutions. So here are a couple practice problems you can work out. I'll give you a couple seconds to do it. Just pause the video. So basically this one, you would just take out the logs. You'll get x plus 2 equals x plus 2 minus 2 minus 2. You'd have x equals x, which is x equals infinite amount of solutions. So basically, infinite amount of solutions means like you can plug in any number you want and you would get the answer. You can try it out if you want to. And then this one, again, same base. You have to look at the base, same base, drop the logs. You get x equals 2. If you plug in 2, you would get this equation. So basically, in summary, log functions are inverses of exponential functions. They do the complete opposite of exponential functions. So if it's 3 to the power of 2, which is equal to 9, the log function would be log base 3 of 9 equals 2. So basically, this gives you the answer, but for this one, you find the power. So another very important thing to do is look at the base before solving, because if it's different bases, you can't really solve it. And then for one-side log problems, always condense the problem and then solve. And then for two-side problems, always cancel the logs on both sides after you look at the base. So that's about it. So thank you for your time.